All right, so with 23, we're still solving the equation, and this is a little different in the sense that we have one fraction equaling another fraction, and we call this a proportion. And with proportions, what we can do is cross multiply. Is probably the easiest thing to do when it comes to trying to solve for t. And so when we cross multiply here, what we're going to have is 2 times the quantity 3t minus 4, and that equals the cross product of now t times t, or in this case t squared. So let's go ahead. We know now that since we have t times t squared, we have a quadratic equation. Quadratic equations, we know that we want to get everything to one side and set the equation equal to 0. So let's go ahead and do that. But before we can set this to 0, let's distribute this 2 through the quantity 3t minus 4 and see what we get. So we have 2 times 3t, so that's 6t, minus 2 times negative 4 is negative 8, again equals t squared. And now we can go ahead and move the 6t and the 8 over and set this equation equal to 0. And we'll do that by subtracting 6t from both sides and adding 8 to both sides. And when we do that, we end up with, I guess I'll write it up here for a little more room, our t squared minus 6t plus 8. And now, don't forget, equals 0. So we have a trinomial, no GCF. The coefficient of our squared term is 1, so we can use the simplified form of either scissors or AC method. So we're looking for factors of 8 that add to give us negative 6. Well, we know this is going to break down into two binomials. We're working with t, so let's break that t down. And now again, factors of 8 that add to negative 6. Well, how about minus 2 minus 4? Negative 2 plus negative 4 is negative 6. Negative 2 times negative 4 is positive 8. And now that we factored the trinomial, again, since we're dealing with an equation, we want to set each of these factors equal to 0 independently. And that's a minus sign, right? So t minus 2 equals 0, and then we'll have t minus 4 equals 0. And solving for t, we'll have t equals 2. Solving for t again, we will have t equals 4. And just like before, what we want to do is make sure that when we take each of these two solutions and plug them in for t, we want to make sure that we don't invalidate any of our denominators by creating a 0, which would give us an undefined fraction, right? So if we take 2 and plug it in, well, we get just 2 in the denominator, right? So that's fine. And then in the second fraction here, we have 3 times 2 is 6, minus 4 is 2, so this one works. And then let's try 4. Well, if we plug in 4 for t, let me get rid of these arrows to make it a little easier to see. If we plug in 4 for t, well, if we plug in 4, we just have a 4 in the denominator, so that works here. And in the second denominator, 3 times 4 is 12, minus 4 is 8. Again, that works. And so our solution, t equals 2 and 4, will be it. And both solutions are valid, and so we will make sure to include both of them in our answer. All right, let's take a look at number 24. I'll see you there.